Okay, let's make sure this is all set up for the short person. All right. Hi, everybody. Thank you for being here. Get ready for some excitement because it's time for Falling Walls Edmonton. My name is Tracy Raivio, and I'm the Vice-Provost and Dean of the Faculty of Graduate and Postdoctoral Studies at the University of Alberta. It's my pleasure to host today's event, and I want to start in a good way with a land acknowledgement. The University of Alberta acknowledges that we are located on Treaty 6 territory and respects the histories, languages, and cultures of First Nations, Métis, Inuit, and all First Peoples of Canada, whose presence continues to enrich our vibrant community. So welcome to all of you. I'm so excited to finally be at this day. I've been looking forward to this for a long time. To those joining us in person here in the TELUS Center, including members of the community and the wonderful alumni and friends who are here for U of A days. I had a chance to speak with some of you. Thank you for coming. And to the people across Alberta and Saskatchewan who are following us online. We're in for a really big treat tonight. We're about to be dazzled by the work of 15 outstanding young researchers. They have powerful stories to tell about ideas with the potential to change the world. Now, some of you may be new to Falling Walls. It's actually my first time being at a Falling Walls competition, so I'm one of those people. And so I think it's worth pausing to offer some background on the competition, just to underscore what these young people have already accomplished. Falling Walls Lab is a pitch competition with a difference. Participants have just 3 minutes to explain their research and convince viewers that it's especially innovative and will make a big impact on the world. They can use a pair of slides to support their talk, and other than that, it's up to them. They have to marshal all their enthusiasm, their ideas, and their creativity to win you over. And it's not any small thing that they're competing for either. The top 2 finalists today will win a trip to Berlin to compete in the global finale. They'll represent our community on the world stage and will enjoy a first-class networking opportunity with researchers from around the world. But of course, all of our finalists benefit from Falling Walls. It gives them tools to talk about their research in a variety of situations, like writing applications and teaching undergraduates and speaking to the general public. So all of those grad students in the audience that haven't competed in Falling Walls or 3MT, consider doing it. It's a really good opportunity to also get some professional development in. I'm pleased to say that we have several recent Falling Walls Lab finalists joining us today. They've done an amazing job as ambassadors for the program, and I want to ask them to stand if they're in the audience. Yeah, there they are. And can we give them a round of applause? Thank you so much for being here and for being great advocates for Falling Walls. Finally, a special welcome to some of the leaders of our community. Please join me in welcoming our Chancellor, Nizar Somji. Thank you for being here. Our Deputy Provost Students and Enrollment, Melissa Padfield. Our Vice Provost Learning Initiatives, Karsten Mundell. And we're also welcoming the Dean of the Faculty of Law, Fiona Kelly. Yay. And we're joined by department chairs, members of the Senate, Board of Governors, and Alumni Council. Thank you, everybody, for coming. It's going to be a real treat. And now it's time to introduce 5 people who are playing a very important role in today's event, the distinguished members of our jury. They are going to be the hardest working amongst us tonight. except for you guys, of course. They come from various backgrounds and bring all sorts of expertise. Each of them is very well positioned to offer our finalists advice, insights, and wisdom. So as I introduce you, I'm gonna ask each jury member to rise and to acknowledge the audience as their name is called. So in alphabetical order, first I would like to introduce Sophia Aziz. There she is. Thank you for being here. Sophia is the founder of Potensia Business Solutions. She has spent over 15 years in the corporate world as a project manager and a business analyst. More recently, she entered the world of entrepreneurship, first as a consultant and then as a co-founder of Potensia. Her passion is helping entrepreneurs build the life and business they dream of by designing and implementing employee-centric systems that increase productivity and profitability. Thank you so much for being here. Our next judge is Paramita Chaudhary Basu. She is the Director of Programs and Ecosystem Development at Applied Pharmaceutical Innovation, an Edmonton-based not-for-profit, where she oversees all programs. An innovation facilitator, scientist, and educator, Paramita also leads the Health Innovation Hub at U Alberta, the University of Alberta's lead life sciences incubator for companies and startups in human health. Darren Fast is also here. Darren is the Associate Vice President, Innovation, Knowledge Mobilization, and Partnerships in the Office of the Vice President, Research and Innovation here at the U of A. Darren's role is to develop and support a clear innovation strategy for the university, utilizing and coordinating existing resources across campus and the community. Bhuvan Manji is also here. Bhuvan is the Director of GTM Strategy for Embedded Finance at FIS Global, one of the world's largest fintech companies. With over 13 years of international experience, he has led strategic initiatives across energy, consulting, and fintech. Bhuvan's work spans advising global giants like Enbridge, Shell, Barclays, and HSBC, as well as shaping digital and sustainability strategies for Bloomberg UK and the European Commission. Finally, we are really pleased to welcome from our neighbor from the University of Saskatchewan, our colleague Leslie-Ann Schlosser. Leslie-Ann is an award-winning communicator and director of the University of Saskatchewan's Research Profile and Impact Unit. With a passion for creative storytelling, she leads a talented team dedicated to showcasing USask's innovative research, scholarly, and artistic works. And there you have it, everyone, our Falling Walls Lab jury. Let's give them one more round of applause. Thank you all. They deserve a really big thanks because we're asking a lot of them tonight. And now, having introduced Darren, I want to acknowledge the significant contributions of the Office of the Vice President, Research and Innovation. They played a big role in funding this event and helping 2 finalists to travel to Berlin. Darren, could you come say a few words on behalf of the office and the University of Alberta? Thank you so much.
Thanks, Tracy. So very happy to be here. I actually had an opportunity to attend the Falling Walls event in Berlin a few years ago. And for all of you participants, I wish we could send you all because it is truly amazing. And what you're going to hear today is about an hour's worth of presentations. There we heard about 7 hours worth of these talks, and by the end of the day it was like, wow, if I wasn't inspired beforehand, I was inspired. And I don't know how you could not sort of think of, wow, the world, we're going to make it. And so I'm just super thrilled that the Vice President's office could support this event, because I do think it is an opportunity for us to showcase some of the great work that is being done here at the University of Alberta and the other institutions who are represented, that the community needs to hear. We need to showcase the great work that's being done here, and not just great because we got it published in journals, but great because it is actually impacting people's lives. And that is what we've got to share here. And so I am really excited to hear your presentations today, and thrilled again that we could support this. Thank you.
Thanks, Darren. And I love that you mentioned hope when you spoke just now, because that is always what I feel when I come and watch these presentations from our students about the research that they're doing, is inspired and hopeful about the future. Now, here's some exciting news. Falling Walls Lab Edmonton has a wide reach this year, with presenters hailing from across Alberta and Saskatchewan. And we couldn't have done it without our new partners, the College of Graduate and Postdoctoral Studies at the University of Saskatchewan. So I want to take a moment and invite Leslie-Ann to bring greetings on behalf of our friends and colleagues at USask.
Wonderful. Thank you so much. It's such an honor to be here today representing the University of Saskatchewan. Just a big shout out to the judges I've met just really quickly in the hallway. It sounds like we have our work cut out for us today. I'm looking forward to it. I am the director of USask's Research Profile and Impact, and part of my job is to help researchers effectively communicate their work to the world. These skills are so crucial, and it's crucial now more than ever in a fast-paced world where there's misinformation out there all the time. And the researchers are the ones who are doing the research, and they can prove the folks wrong, and you have the right ways and processes to do that. So what we're going to hear today, I'm very much looking forward to it. It's amazing to see young researchers dedicate some time and talent and effort into this type of program, and telling us your research story. Darren said it so well. It's not necessarily publishing in journals anymore. We want to make sure that we're publishing journals, but also telling our story to the media and to government and to the decision makers. And the more effectively you can do that, the more we're going to move the needle together. At USask, we believe in the power of these types of opportunities, and we're committed to supporting our researchers and making groundbreaking contributions to society. Sounds like Falling Walls embodies this mission, and we're so proud to be a part of it here today. It's just a wonderful opportunity. I'm looking forward to being wowed tonight. And it's just an amazing way to hear what work you're working on. So thank you so much, and good luck to all those tonight. Thank you.
Thank you, Leslie-Ann. No pressure, you guys. And now for our program. Here's how Falling Walls Lab will work tonight. Each presenter will have 3 minutes to present their pitch. A reminder signal will be heard when there are 10 seconds remaining and when 3 minutes have elapsed. We'll pause for 60 seconds after each presentation to give the judges a chance to tally their results. And during that time, the next presenter will get in place and will announce their names. So I'm going to turn things over to Rob now so that we can dive into the exciting part of the night.
Thank you very much, Tracy. And it's now my pleasure to introduce our first 5 presenters. We're going to introduce them in groups of 5 tonight. So the first 5 presenters are Abdul Saboor, Albin Joseph, Pulkit Kumar, Sarah Hassanpour Tamran, and Zach Kaal. Good. Great. We'll turn you on. All right. So when you're ready, Breaking the Wall of Thermal Energy Storage, Abdul Saboor.
Hello. Isn't it amazing how a simple thermos can keep our coffee hot all day long? Now imagine the same thing, but on an industrial scale, storing heat not just for hours, but for days, not just at 100 degrees, but at 1,000 degrees. Industries, especially those who are relying on renewable energy like solar power, they need a way to store heat because, let's face it, the sun doesn't always shine, especially here in Edmonton. And that's where thermal energy storage comes in, a way to provide industries with continuous reliable heat. Traditionally, this is done by using molten nitrates, which are stored in steel tanks. But there's a wall. These nitrates decompose at temperatures beyond 600 degrees, making them useless for industries that need higher temperatures like metal treatment. And those steel tanks are incredibly expensive, driving up the cost of the overall system, which is why industries hesitate to adopt them. This is where our work comes in, developing low-cost, high-temperature thermal energy storage. We have developed a way to store heat at temperatures up to 1,200 degrees using a different type of salt called a binary chloride salt, a combination of sodium chloride and potassium chloride, two forms of table salt. These salts have higher thermal capacities, meaning they can store more heat for the same mass. On top of that, they're cheaper, more abundant, but most importantly, they don't break down at high temperatures. This simple yet powerful solution enables us to achieve the extreme temperatures needed for industrial processes. But the key innovation isn't just the salt, it's the tank itself. We have engineered low-cost concrete-based tanks and tested them under aggressive thermal cycling, heating and cooling them daily to simulate real-life conditions. We used a solar flux simulator, which mimics the sun, to heat the salts and test their resilience under the extreme conditions. And they managed to survive even for hours, even for days. And we ensured their reliability even in the most extreme of conditions. Now imagine what we could do for the environment if we put the same thing on a bigger scale and allow companies to switch fully to renewable energy. But that's only possible with solutions like ours, which provide double the temperature at half the cost. We are paving the way for a sustainable energy future, one where clean energy isn't just possible, it's practical, affordable, and reliable for everyone, which makes this, quite literally, one of the hottest new developments. Thank you.
Breaking the Wall of Inefficient Ventilation, Albin Joseph.
Do you remember those days when we were within the four walls of our home? Yeah, the COVID-19 pandemic. Outdoors were a kind of mythical land for us. Looking out through my windows, many times I felt jealous on those prairie dogs hanging around with their family, boyfriend, girlfriend. On the other hand, it was a situation where we had to think twice, even before breathing. And here is a fact. The quality of air that we breathe can affect our health and productivity. People spend more than 90% of their time indoors. The case of coronavirus is just one example of indoor contamination, while there are many other contaminants that can affect your health and productivity. Hence, the indoor air quality has a significant role in our day-to-day life. One of the potential ways to improve the indoor air quality is by increasing the ventilation. But that will increase the power consumption of our heating device as well. The HVAC engineers over here might ask, why can't you use an ERV? ERV, the energy recovery ventilators, are a potential option as it can extract heat and moisture from the outgoing contaminated air and transfer it to the incoming fresh air, thereby reducing the power consumption of our heating and humidification devices. Here is a billion-dollar question. Won't this ERV also transfer contaminants? Our research on this aspect has ended up on membrane energy exchanges as a potential option to transfer heat and moisture by filtering the contaminants. This is not just about a membrane, but a membrane in the form of an exchanger between two streams of air. The properties like thickness and surface wettability of the membrane can drive the heat and moisture, while the pore size were optimized to filter the contaminants. By doing so, these membrane energy exchanges can significantly reduce the heating and humidification load and thereby ensuring good indoor air quality. After all, it's all about the law of nature that we human beings are what we eat, drink, and breathe. We can survive without food and water for days, but not without good quality air. So break the wall of inefficient ventilation for a healthy and productive future. Thank you.
Breaking the wall of islet transplantation. Pulkit, Kumar.
Every 6 seconds, a life is lost due to complications from diabetes, a stark reminder of its devastating impact. Among its forms, type 1 diabetes poses a unique challenge as an autoimmune condition that targets and destroys insulin-producing islet cells. But imagine a future where a single procedure offers a lifetime of relief. This isn't just a hopeful thinking, it's the potential reality my research is striving to achieve. Thus far, less than 1% of type 1 diabetes patients in Canada have undergone islet transplantation, locally known as the Edmonton protocol, that promises freedom from daily insulin injections. Yet the success of these transplants is hampered by rapid cell death, as most cells die within days due to harsh immune reactions and other forms of cell death. My approach introduces an innovative approach using tiny microparticles. These tiny carriers encapsulating anti-rejection drugs and cell death inhibitors directly to the transplanted islets, offering a localized drug delivery system that shields them during the critical early days post-transplant. This method not only diminishes cell death, but also enhances cell survival rates and has the potential to turn the tide in islet replacement. Importantly, this means that patients no longer have to take daily anti-rejection medications, thereby simplifying treatment and mitigating the toxicity of current drugs. Implications of this research extend far beyond the lab and the hospital. By improving the success rate of transplants, we reduce the need for multiple donors per recipient to just one, reduced healthcare costs by billions, and most importantly, improved the lives of millions living with diabetes worldwide. Notice how I didn't mention type 1 or type 2 diabetes, but diabetes in general. So why does it matter? Because it's more than just about diabetes. It's about how we tackle complex healthcare challenges globally with innovative thinking and empathy. This research with microparticles has the potential to turn the tide in other drug treatments, including cancer and arthritis. Breaking the wall of diabetes treatment isn't just about the scientific challenge, but it's about giving people better tools to help mitigate and severe complications and ensuring that more people live longer and healthier lives. Together, we can dismantle these walls one microparticle at a time. Thank you.
Trying to hide it.
Breaking the wall of early cancer detection, Sarah Hassanpour Tamrin.
Hello, everyone. Let's take a breath and let it go. Ready? It typically takes 3 seconds. Did you know that every 3 seconds, every time that we breathe in and out, someone dies of cancer in a world? And only in Canada, from every 2 Canadians, 1 is expected to be diagnosed with cancer. And sadly, half will not survive. But it's not going to be the whole story. Evidence shows that when cancer is diagnosed early, there is a time to start a proper treatment. And survival rate increases more than 90% in many cases. However, most cancers are being diagnosed very late. The issue is that current diagnostic tools are not sensitive enough to find cancer signs in our body at the earliest stage. Some of them are very expensive. Some of them, like tissue biopsies, brings discomfort for patients to use it regularly, like a routine checkup. Of course, we need a more convenient tool, like a blood test. In a typical blood test, a couple of milliliters of blood will be collected to look for cancer signs. That can be some metabolites or biomarkers released from cancer cells. But the issue is that quantities of these biomarkers in our blood at the early stage of disease is really low to be detected accurately. You know what? We need a novel technology or a novel biomarker. Today, I am here to introduce the game changer, Exosense. Exosense is a novel technology that looks for exosomes, a novel biomarker. Exosomes are super tiny particles released from any type of cells, including cancer cells. And so when they are released, we can find them in our blood, urine, saliva. They are everywhere in our body. And the point is that when they are released from cancer cells, the quantities in our blood at the earliest stage of disease is really high compared to other biomarkers. If we have a technology to be able to take these cancer-related exosomes, then we have a chance to find cancer very early just by testing 1 drop of blood. Exosense, this is a small device that we typically fabricate in our lab. So it's composed of multiple electrodes because we found that exosomes, when they are coming from cancer cells, they generate a particular electrical signals can make them differentiate from the other particles in our blood. The technology is super cheap. Just a few dollars per chip is the cost of technology. It's user-friendly and very fast, which make it accessible and affordable for everyone in the world. We are testing the technology with different types of cancer to bring the technology one day from the lab to the market, with this hope to be able to find cancer earlier when there is a time to start an effective and efficient treatment. Thank you.
Breaking the Wall of Renewables, Kaal.
We are addicted. We've been addicted for over a century to fossil fuels. It started off simple, fueling our homes, powering industry, but just like any other addiction, it slowly spiraled out of control. Now we're dependent. We need that daily fix of fossil fuels. It's what makes modern life livable. But it's costing us far more than we could have ever imagined. In 2022 alone, we've pumped over 36 billion metric tons of carbon dioxide into the atmosphere, pushing global temperatures higher, triggering more intense natural disasters, and wreaking havoc on ecosystems around the world. And the damage isn't just environmental, it's deeply political too. We've seen wars fought over oil and economies crippled by fluctuating fuel prices. We know we have a problem, which is why countries around the world are racing to meet their net zero emissions targets by 2050. But we can't just quit fossil fuels overnight. We rely on crude oil to make everything from gasoline, electricity, heating, cosmetics, pharmaceuticals, plastic, and much, much more. We haven't been able to quit because we haven't found an alternative that can match the sheer versatility that crude oil offers. Not until now, at least. At our lab, we've developed a simple, first of its kind breakthrough process that can take any waste fat or lipid and turn it into a renewable crude that's chemically identical to the crude oil we pump out of the ground. This isn't just a substitute, it's a game changer. Because it's identical to the crude, we can use our renewable crude in the current infrastructure that we've already built for the petrochemical industry. The best part about our process is it's extremely simple. All we need is water, heat, and nitrogen. And any waste fat, no matter how dirty it is, can be converted. The implications are enormous. By converting waste products into a renewable crude, we can still harness the same benefits we've gotten used to from fossil fuels, but without the environmental damage, helping us meet our targets by 2050 and beyond. In addition, nations can gain energy sovereignty by being able to make their own crude from their own waste. And this technology isn't a distant dream. It's been patented, and we're in the process of building our first commercial plant. It's already triggered other research areas, such as research into bacteria that can consume carbon dioxide and turn it into fats, paving the way for a future where we can turn air to energy. Other research is looking at using our renewable crude to make sustainable aviation fuel for a sector that's in desperate need of a green alternative. Fossil fuels aren't a lifeline, they're a crutch. This technology helps us break our addiction, keeps the world working, and keeps our skies cleaner and our future greener. Thank you very much.
Thank you. Our next 5 presenters are Alexandra Gagnon, Sushmita Mittra, Dishan Burad, Matthew Dixon, and Anna Stepanchuk. Breaking the Wall of Community Reentry, Alexandra Gagnon.
If I gave you $119,000 to take your dream vacation, where would you go? Well, ready your passports, because with that kind of money, you could go anywhere. Now, what if I told you that's how much it costs to incarcerate one person in Canada for 1 year? For a system this expensive, surely it proves effective in reforming people, right? Well, unfortunately, that's not the case. Around half of the people who leave prison will go back. The problem is they're often caught in a revolving door. entering and exiting prison over and over again. But how does this happen in Canada, globally known as a utopic society full of social services? I'm part of the University of Alberta Prison Project, a groundbreaking research study never before done in Canada that is answering this question. We are conducting interviews and surveys with over 1,000 people from their prison release date to 1 year later. Our research is uncovering the many challenges they face and developing actionable solutions. Our findings are startling. On average, our participants have been incarcerated 11 times, mostly for crimes of poverty and desperation. And for many, their life circumstances in the community are so dire that they see prison as the better option. An example of this is Aaron, one of my participants who is unhoused. When Aaron was released from prison, he only had the clothing he wore while arrested. No money, no phone, and no ID. Because Aaron didn't have ID, he couldn't access housing or open a bank account, which blocked him from getting a new phone. See, Aaron was supposed to call his probation officer within a week of his release, except he couldn't access a phone. Because he couldn't make that call, he'll be charged with a breach of conditions and a warrant put out for his arrest. Aaron told me, if things get too rough on the streets, I can turn myself in and get a break. Let me make it clear. Prison is not an all-inclusive vacation. The conditions are often harsh, overcrowded, and violent. The fact Aaron sees prison as the better option just shows how broken our welfare system is. By being the first systematic study on barriers to reentry in Canada, our research will pave the way for meaningful change in future studies across the globe. Maybe we could provide people in Aaron's situation an ID when they're released, so then they can access services in the community instead of going back to prison. It's been found that by investing in social and correctional community services, we can reduce the cost of incarceration from $119,000 to $31,000 a year. The revolving door of prison harms everyone, but particularly those that are caught in it. When we think about the purpose of prison, reform, you should only have to go once. And who knows, maybe with all that money we'd save, you could take that dream vacation you were thinking of earlier. Thank you.
Breaking the Wall of Abattoir Waste Upcycling, Sushmita, Mittra.
Imagine you're at a grocery store to buy beef. Did you know that to get that perfect cut of beef that you just bought, about 60% of the cow went to waste? 9,000 cows are slaughtered in Canada every day, generating about 3,000 tons of beef waste per day. Add to that waste from slaughter of other animals, and you have a ginormous amount of waste going to landfill. Now, why is that a problem? First, imagine what you could have made but threw away instead. And second, landfills produce methane, so you just exacerbated global warming. So what do we do with slaughterhouse wastes today? We collect them as a mix, sort them into components, pick one component to make one product, and the rest goes to landfill. Here's my solution, and this is why it checks all the right boxes for the environment. First, you can process slaughterhouse waste as a mix, so no segregation needed. Second, you can do combined processing with other kinds of wastes, utilizing co-processing synergies. Third, you produce a suite of different products, maximizing your profits. And finally, nothing goes to waste. And this is innovative because currently there's no such model for slaughterhouse waste. And there's also no facility that can produce all the products. The benefits of my research can be felt at 3 levels. At the local level, slaughterhouses don't need to pay to get their waste collected. They can decide what products to make that they can then use in-house or sell. At a regional level, by co-processing different wastes, you address a wide range of waste management problems. And at the global level, first, you make the meat industry more sustainable. Second, by utilizing wastes as raw materials, you implement a circular economy. And third, since you utilize your wastes, you dispose less, saving land and reducing greenhouse gas emissions. My research is inspired by the indigenous peoples of Canada who have lived off of the land sustainably for thousands of years. Every part of the animal they hunted was used either for food or as items of utility. Let me leave you with this question. When we think of progress, we always envision moving forward. But when it comes to sustainability and environment, could taking a step back be our only way to move forward? Thank you.
Breaking the wall of opioid overdose deaths, Dishan, Burad.
Who here knows someone who's used opioids? Maybe on the streets, maybe in a hospital. Well, I do, and I've seen how it can affect people, like how it affected my mom, a florist who had to send flowers when youths in their 20s died because of an opioid overdose. World over, 600,000 people die each year from an overdose. There is a medication called naloxone that reverses the effects of overdose. So why are people still dying? The problem is that current naloxone kits are deficient when it comes to drug users who are incapacitated because someone else has to administer naloxone to them. And naloxone only temporarily reverses the effects of an overdose. So how can we deal with this? The solution would be for the drug user to be able to self-administer and also be able to get to a hospital before their overdose reoccurs. For the past year, I've been working on a solution, innovative solution to address just this. It's an automated injector that works based on biomarkers like heart rate and sends a signal to emergency services. The idea is for the drug user to put on an armband, which has a patch containing naloxone, an automated injector, a heart rate sensor, and a Bluetooth transmitter. So when the person uses opioids and they overdose, then that makes their heart rate plummet, causing the automated injector to pump naloxone into them, and then also send a signal to local emergency services. In Alberta, where I live, you can get a naloxone kit at any pharmacy for free. In the same way, I hope to be able to get these naloxone injecting armbands at any pharmacy. That way, people will be able to self-administer the medication and get much quicker access to emergency services. Opioid overdoses are extremely traumatic experiences for both the drug user and for the people in surroundings, including first responders, but they don't have to be. By using my naloxone injecting armband, not only will we save these people, but we will alleviate some of the trauma caused by these opioid overdose deaths. So someday, people like my mom won't have to send flowers to youth in their 20s who die. Thank you.
Be a long 45 seconds here.
Right. Breaking the wall of nature's reactions, Matthew Dixon.
If you've driven along one of Alberta's beautiful highways, you've probably seen a flare tower. These towers work to convert methane, CH4, produced during natural gas extraction, and convert it to carbon dioxide, CO2, before releasing it straight into the environment. This process does avoid simply emitting methane, itself a potent greenhouse gas, but still results in significant carbon dioxide emissions. Methane can alternatively be used as a valuable starting material for a range of chemicals and liquid fuels. However, reactions to convert methane into these upgraded products are limited by a need for high temperatures and inefficiencies. Unfortunately, this leads to methane flaring at many remote extraction sites, essentially burning money. This problem has persisted for decades and has cost the oil industry about $10 billion a year while producing 1% of global greenhouse gas emissions. What if I told you the answer to this problem had already been found? In nature, bioorganisms are able to efficiently use methane to build complicated molecules and liquid fuels. So how do they work, and can we learn anything from them? These biological reactions proceed through a fundamentally different pathway than chemists have traditionally used. I like to think of it as a moving trip. Imagine you're moving and you're bringing your dog and your couch with you. Chemists have been taking two trips to avoid squishing things in the car. What nature's figured out is that you just have to bring a trailer. With the dog in the car and the couch in the trailer, you only need one trip. I worked to develop a molecular model of this system. In my system, a metal cluster acts as the truck, and it tows an attached basic site, the trailer, providing an ideal platform to understand how this alternate pathway works. These clusters are highly customizable and allow for a wide range of precise adjustments to be made. By making adjustments to the properties of the two sites and modifying the distance between them, I can work to create molecules with similar reactivity to their biological counterparts. Understanding how nature's reactions work could enable the development of a more efficient industrial process for converting converting methane into liquid fuels. Additionally, these clusters could provide fundamental insights into how chemistry can help us do, or how biology can help us do better chemistry. This pathway is key to a wide range of additional processes that could change how the world thinks about producing fuel, growing food, and dealing with waste. It turns out that the answer to some of our newest problems has been under our nose for billions of years.
Breaking the Wall of the Memory Maze, Anna Stepanchuk.
If you were to find yourself in a room that you don't recognize, surrounded by complete strangers telling you things that don't make sense, how would that make you feel? You'd probably be terrified. And this is a daily reality for people with Alzheimer's disease. And I'm willing to bet that everyone in this room knows of someone with AD. It's heartbreaking for caregivers to see their loved ones slowly fade away, needing more and more care with no hope of a cure. People with dementia become more apathetic, more disoriented as they gradually lose more of their memories. But what if a simple scent from their past could offer them at least a moment of solace, even if the conscious memory triggers is no longer there or accessible? Something as unassuming as a woolen ball that smells like apple pie. It's simple, it's easy, and most importantly, it's comforting. I have come up with a way where people can create scents that give them a sense of safety and make them feel more at home within themselves. And over the last year, I have created a database of emotional responses of different scents between and among healthy individuals. Now, I want to bring this to dementia patients. People at early stages of dementia can attend my workshops and create the scents that make them feel connected again. And what if we could match the scent of safety with a person that is no longer verbal at more advanced stages of dementia? We could do that by measuring brain and body responses to different scents with patients who are unable to communicate that anymore. Scent is a powerful tool that transcends words, that allows everybody to connect, even in the fog of the memory maze. If we had a personalized scent for every single patient, can you imagine how much easier it would have been for caregivers to provide for their loved ones? We might not even need to administer drugs to those patients that they might not even need, such as sedatives or antipsychotics. And even as people navigate the fog of the memory loss, they're still able to connect with their loved ones. This does not have to stop at Alzheimer's. Since scent is such a transformative tool that does not require words and reaches the deepest centers of your memories and emotions, this can be applied to other disorders of the mind that affect people of all ages. And at the end of the day, I want you to think back to that unfamiliar room. But instead of being confused, you now have a thread, a strong thread of hope that guides you out of the memory maze. And that thread is scent. And in that case, hope is what it gives. Thank you.
And our last five presenters are Lily Jo, Priyanka Chirumareddy, Rajas Shah, Luisa Pessoa Suarez, and Benjamin Kucher. Breaking the Wall of Broken Arm Detection, Lily Jo.
Last year, my friend Kevin hurt his wrist while skiing, and he had to go to the hospital for an X-ray examination. After waiting 4 hours in the ER, he was told that he did not have a fracture. The waiting time sounds frustrated, right? Unfortunately, that is a common experience for anyone with a suspected fracture. Surprisingly, 45 to 80% of the patients go to the hospital with wrist or elbow injuries actually do not have a fracture. Besides, wrist and elbow fractures are among the most common fractures from young children to the elderly people, with over 2 million cases per year in North America. Is there a way to change this? Absolutely. Thanks to the groundbreaking advancement of artificial intelligence, I am the first and only one in the world found that AI can use ultrasound images to detect wrist and elbow fractures as accurately as a professional doctor using an X-ray. Based on this, we proposed a revolutionary solution. We have developed an AI-driven app for wrist and elbow fracture detection. By connecting a pocket-sized ultrasound probe to a cell phone with our app, guided by AI generated by me, anyone with just 15 minutes of training will be able to use this tool to assess arm injuries. Our app will provide an instant and explainable report explaining your bone shape in detail. Using this tool, only patients with fractures need to go to the hospital for further examinations and treatment. This could relieve the burden of emergency department and save hundreds of millions of dollars in North America every year, while assuring the accurate diagnostic care. Just like Siri and Alexa can be your personal assistant, imagine having AI as your personal doctor. We aim to start with wrist and elbow fractures and gradually expand to cover fractures all over the body, like shoulder, hip, and even other diseases. This tool can be used in places like ER, community center, school, ski resorts. It could even become a household medical device like a thermometer, benefiting anyone, anywhere in the world. In the future, if someone hurt their arm on the slope like Kevin did, they won't have to spend hours waiting in the hospital. They could receive the timely and accurate diagnosis locally. Well, of course, I hope everyone stays injury-free and never needs our product. Thank you.
Breaking the wall of fossil fuel dependency, Priyanka Tirumareddy.
Remember when summers were more about beach trips, barbecues, and ice creams? Now we are melting faster than the ice cream. Thanks to climate change, our summer plans are more about escaping heat waves than catching rays. What is driving this? The rise in global temperature is closely tied to increasing amount of carbon dioxide in the atmosphere. And a big part of the problem, yes, the transportation sector. It accounts for 20 to 24% of global CO2 emissions, mostly from burning fossil fuels. So how do we fix this? Well, one solution is to replace fossil fuels with renewable alternatives like biofuels. In Canada, we have already made some progress through clean fuel regulations. These rules require that at least 5% of the fuel we use in our cars need to be blended with renewable ethanol. But this is coming from food crops like corn and wheat. Using food for fuel raises concern about food prices and food security. What is the alternative? That is where my research comes in. Instead of relying on food crops, we are focusing on non-food sources, especially agricultural waste, like canola and mustard oil pressing residues. But these non-food crops have complex fibers, and the microbes can't readily break them down into fuels. In our lab, we are working on breaking those tough fibers by treating the agricultural waste in the presence of high temperature, pressure, and using materials like molybdenum and carbon. Think of them like a pair of scissors cutting through those tough fibers and making it easy to convert agricultural waste into fuel. Canada produces about 10 million tons of canola and mustard meal combined each year. With our process, we could convert that into 2 to 3 billion liters of biofuel. This can be blended with petroleum fuels, and it has the potential to reduce 7 to 8 million tons of carbon dioxide emissions every year. So therefore, it is not just about enjoying summers without worrying about extreme heat waves. It is about creating a sustainable future where we don't have to choose between feeding people and fueling our world. Thank you.
Breaking the wall of sustainable carbon fiber, Rajesh Shah.
I have a weight problem, racket weight problem, that is. This racket is very heavy and it's made of metal, and it costs me a couple of extra calories just to complete this swing. Similarly, our cars are also heavy. Most of the car parts are made of metals, and that's why we need extra fuel just to burn them and drag their own weight. So we need lighter alternatives to make these cars. Enter carbon fiber. This structural material, which is light as hair and strong as steel, has been found in high-performance cars, where every gram of weight matters for that split-second advantage. So why don't all our cars are made of carbon fibers? Why isn't this racket made of carbon fibers? It's because carbon fibers are expensive to manufacture and cost a lot of energy. Most carbon fiber industry is supposed to grow from $7 billion market today to about $23 billion by end of this decade. So question comes, how do we sustainably increase this demand and make them more cheaper alternatives? We look into what the manufacturing costs are. It turns out 51% of this manufacturing cost comes from the precursor, a very energy intensive material that is derived from petrochemical industry, where we solve this problem by looking into another problem of petroleum industry, asphaltenes. A waste generated by crude oil refining is creating havoc in today's world. In Alberta alone, we're generating asphaltenes which are up in the range of 22 swimming pools per day. This is a low-value waste is combusted as a cheap fuel or just discarded away. So instead of using refined chemicals, why don't we use this waste to make carbon fibers? Well, what we look is if we chemically and thermally treat this material, we can turn them into fibers and then further carbonize them, making them into carbon fibers. With this methodology, just by replacing the precursor, we'll reduce the cost of carbon fiber by 60% and make them reduce GHG emissions by more than 50%. With these applications, with just 10%, even if today's carbon fiber, just 10% of worth of carbon fibers are replaced with this precursor, it would be as good as taking away 50,000 cars from the road for an entire year. Just imagine the structured materials that we can make lightweight, right from our sporting goods to all spacecraft. And applications would be endless. So next time when you're out to buy a racket, or when you're out to buy a car, know that we are striving to make them lighter. Lighter on your wallet, lighter in your hands, and most importantly, lighter on the environment. Thank you.
Breaking the Wall of Autoimmune Diabetes, Luisa Pessoa Suarez.
The first years of your life define who you become. That's when your immune system develops and reacts to everything around and within you. And then your story can go into two very different directions. On one hand, you can develop a protective and effective immune response with minimal damage to your own cells. On the other hand, you can develop high chance of inflammation and even chronic disease. But the problem is, so far, we don't know for sure how this decision is made, which gives urgency to research that looks into this decision-making process and tries to understand it. One clue that we do have so far is that the microbiome heavily influences this decision, especially the microbiome that you receive during the first period of your life, through birth, and that's modulated through breastfeeding. However, one sad example of this is when the communication between this microbiota and your immune system leads to a severe and so far incurable disease called type 1 diabetes, a disease marked by the immune destruction of your pancreas cells, leaving the person affected to be permanently insulin dependent. But what if this communication and this trigger could be prevented just by modulating this microbiota and this initial communication? That's where our project comes in. That's where my research comes in. So for that purpose, we use a mouse model that has a genetic risk for type 1 diabetes. And then we study the specific bacteria, the species, the antibodies and proteins that are part of this communication. And that not only we understand this process better, but we also can look at factors that are naturally afforded and could even prevent this trigger from ever happening, so that the disease will never even happen in the first place. What makes my project very important is because 9 million people worldwide have type 1 diabetes. 300,000 just here in Canada, maybe people in this very room. This number is expected to double within 15 years, unless projects like mine can contribute to prevention and protection of people from development of this disease. My research can look into these maternal factors and can lead into research that would maybe apply these factors into early life healthcare protocols, such as probiotic supplements or vaccines can be used to decrease type 1 diabetes everywhere. And then people can be protected against this disease and type 1 diabetes even before they learn to speak that word. Thank you.
Breaking the Wall of Beads and Boundaries, Benjamin Kuchar.
I want you to consider this jar of beads and imagine them being passed from hand to hand and traveling thousands of kilometers, and finally being stitched into a medallion like the one you see me wearing tonight. What stories could they tell? Each one of these beads holds within it the power to rewrite the story of Canadian history and our understanding of global trade. For decades, archaeological research has focused on the physical attributes of these beads, their size, shape, color, and even the material they're made of. Beads and Boundaries represents a substantial shift in archaeological methods. It represents us, or it challenges us to rethink the way that we look at objects and look at them as aspects of the culture. It is one of the first studies of its kind, and it integrates different methodologies from different disciplines, including chemistry, art history, economics, physics, and of course, archaeology. Beads and Boundaries pushes us to understand the ways in which everything we do is connected. In my work, I have been able to map the extensive trade networks that these beads have traveled and trace their origins. But this work goes beyond tracing trade networks. It unveils a complex web of cultural practices that were central to the Métis. It reveals a people that were deeply involved in commerce and exchange. Beads and Boundaries is one of the only studies in which we have traced from Venice, Italy, to right here in Métis communities in Edmonton. And working through this, we've been able to understand the different ways in which the Métis have been involved in global commerce, looking at how a bead in Italy connects Italians to the Métis, the indigenous people of Canada. And thinking about the material that things are made out of, I want you to consider the rings, watches, and the different accessories that you own. And I want you to ask, what stories will they tell? Are these just mere objects, or are these significant objects that represent significant chapters of your life? Thank you. You want me to read this?
Wow. Good job, you guys. Did I tell you? Do you feel hopeful? Do you feel inspired? Do you feel like the future looks bright? I do. Thank you for that, all of you. Let's give them one more round of applause. Okay, I'm going to ask Renee now to escort the judges to their deliberation room. Don't get up anybody, though, except the judges. And while they do that, I'd like to call all our 15 presenters to the front. Come on up here, and we're going to have a chance to ask them questions. I know I have a lot that came into mind while they were talking. Come on up here. Take this out. So if you have a question, you can put your hand up and Rob will bring you a microphone. And we have all of our speakers here to answer any burning questions that have come into your mind while they were talking. Take advantage of the fact that we have all of these great students in the room to tell us about their research. Nobody wants to be first at the back up there? No? I don't know if he has a question or if he was just waving. He's just waving. Okay. Now you have to ask a question. No.
Well done. That was amazing, each and every one of you. I'm just going to pick a couple random names because if everybody wants to answer, we might be here for a while, but I'm just looking for what inspired you. So if I may ask, Albin Joseph, and then maybe Matthew Dixon, and then maybe, is it Raja Shah? If that's three, if that's okay. Just what inspired you to come up with your
Great
projects
question.
today?
Who wants to go first?
Sorry, can you repeat that?
What inspired you to come up with
The thing is, we're trying to replicate or reinvent what is materials out there. We already have structural materials or these carbon fibers which are light, but currently their applications are not realized to their full potential. And that is because of this precursor that is very expensive. So the inspiration really comes up if we can find an alternative starting material so that our end final goal becomes very cheap and it's also more effective. And that's the basic inspiration behind the project there.
Who else did you?
Albin.
Hi. So from beginning, actually, I'm running a startup through my university incubation center named Opus. And I was looking for various pitching events. And while going through, though, I noticed a mail from the university in letterhead, pitch your idea. So that's the first strike. So I went ask something like anything. And eventually that I came up with my research idea that I should have to say, which was something which the society wasn't thinking of. Because during COVID-19 pandemic, there were government regulations saying that stop to use the ERVs, especially from schools, hospitals. And the fact is that even those regulations were not clear that if these HVAC system would actually transfer these contaminants or if that are dangerous for the society or the occupants. So we got a project from the government of Canada, from NSERC, and we were working on that project. And unfortunately, a couple of our results were unfavorable to the occupants, while we ended up on a system that can protect the occupants from the contaminants, especially due to the COVID-19 pandemic in view of coronavirus. And we have tested various contaminants like particulate matters, even with the collaboration with our health departments. So that's what I thought of sharing it with you, like just for a general awareness that we might be safe at some points, but we might not be safe at all points. So that's the main thing. And yeah, I think I did my best. Yeah.
And Matthew.
I'm a big fan of like being outside. I like hiking and camping. And I think it's pretty cool that like trees are able to do the most efficient chemical reactions in the world, right? Like they put what we do and what industrial chemists do to shame. Like everything you can see working outside is pretty incredible. And I think, understanding how those mechanisms work is a really valuable pursuit. And it could also let us have like, I think it was you that made a comment that, and it's a good point. Like, maybe one of the things that we have to do going forward is slow down and sort of deindustrialize. I think you can probably make a pretty good argument that there are ways forward that are more sustainable where we don't have to make those trades. And I think that's a lot easier to convince people of as sort of an idea going forward. Is, hey, we can do these cool things, and look, here's proof. There's a tree that does it outside. Yeah.
I love that. Okay, other questions? Oh, Rob's running.
Firstly, good job, everyone. I personally know it's not an easy feat to do, so good job today for sure. I have questions for two different presentations. Firstly, for the Islet transplantation presentation from Pulkit, you mentioned these microparticles. So kind of my questions are, what are these microparticles made of? How do you deliver them locally? And what's the advantage of delivering all these locally versus a systemic, anti-immune response drug dosage?
Yeah, amazing question. Thank you so much for asking that. So these are made with something called PLGA, polylactic glycolic acid. Name sounds like an strong acid, but it's not. It's a very weak acid. And we have our own protocol to encapsulate something called a necrostatin-1, which is a cell death inhibitor, into these microparticles. And they are delivered via portal vein into humans, whereas in mouse or animal models, they are delivered under the kidney capsule. And thus far, my research has shown that with the amount of ER stress is, again, endoplasmic reticulum stress, which is inside the body, kills the cells, most of the cells. But with these microparticles, we are able to protect most of the cells. So for instance, if let's just say I delivered 10,000 islets, at least 8,000 islets remain after a week or two. And the animals, they get normalized. So normalized, it just means that their diabetes, it reverses. What was the second question, sorry?
How are they delivered locally? How do you said, because they're mainly, it's a localized delivery, right?
So they're delivered with islets.
And then
that creates a localized drug delivery system because the drug is already inside of you.
it doesn't spread to other places
No.
in the body?
No. So there's something called a bulb C serum. Bulb C serum is again a serum we extract from mouse models, which helps them keep these particles and these islets in that particular region. And what was the third question, sorry?
What's the advantage versus basically what they do now, which is kind of systemic, anti-inflammatory drugs?
Yeah, so just like any other anti-inflammatory or cell death inhibition drugs, necrostatin 1 is, it specifically focuses on something called necroptosis. So there's two forms of cell death, apoptosis, necroptosis. Apoptosis is more so a programmed form of cell death, a natural form. Necroptosis, what it does is, so let's just say there's a cell in the body and the cell is like, you know what, there is a problem inside of me. I'm going to kill myself, but I'm going to attack all of the other cells. So that creates inflammation. That's what necroptosis is. Necrostatin 1 inhibits that with something called a RIPK1 and a RIPK3 pathway. That's just the mechanism of how it inhibits. But the idea is to create a long-term sustainable solution because these patients, they have been taking anti-rejection drugs daily, and that's not sustainable. So how about we put those drugs inside of their body so that you don't have to miss your kids' soccer games. So that's the idea. That was something we were planning, and even globally, my initiatives, we always sort of focus on sustainable healthcare delivery, not just in Alberta, but in LMICs, low to mid-income countries as well.
Perfect, thank you. Thank you for nerding out with me. I'm in cell bio, so I know a little bit of the terms.
Amazing, thanks for all the amazing questions, thanks.
Thank you. And just quickly, for the early cancer detection talk, for the next talk, so you said you detect, like you have that chip, you have the early cancer detection through, you said, I think, electricity, but how do these, when you're looking at the exosomes in your sample, are you looking at the actual biomarkers on the exosomes, or are you somehow detecting some proteins on the exosome? Or are you actually looking at electric signal, or how does that kind of work?
That's a good question. You know what? Actually, I really wanted to explain that in my presentation, but the time was the limitation that I was not able. And I'm happy that you asked this question. So I said that exosomes are released from any type of cells, healthy cells, diseases, everything. We need to discriminate, cancer-related exosomes from healthy one, and also the other particles. So the point is that when cancer-related exosomes are released from cancer cells, they contain some informations from the cells. And those informations are proteins, lipids, RNA, DNA. So those are free biomarkers that are available in our body. And so the techniques that I said, the conventional techniques, are looking for those biomarkers. But when they are packed into the exosomes, so they are safe. And so our research showed that the content of exosomes will be reflected to the electrical signals. I'm saying electrical signals that can be surface charge, for example, or the electrical conductivity of the blood, or urine, or saliva that contain those type of exosomes. So our project, our device is grabbing all those information, surface charge, dielectric response, conductivity, everything from different source of cells, and make a library of, that's going to be like a matrix of information. And then we categorize the source of signals that we have to discriminate healthy one from the diseases. And the other things that I'm going to take this opportunity to share with everyone is that this device has the potential to be extended to detect different type of cancer cells. So I'm saying that the content of exosomes, when they are coming from lung cancer, will be significantly different from bladder cancer or the other things. And that will be reflected on those electrical signals.
Thank you so much. I'll stop bothering you guys. Good luck.
So cool. Hey, way over there. Rob, you're getting your steps in here.
Phil Donahue today.
Maybe I'll ask a question while you're running. I have so many. So your AI tool for broken limbs, like how close is that to like a reality? Yeah. I mean, yeah. Is that
Yeah, like I think based on the oh, sorry. Sorry. That's a very good question. So, like based on the data set we collected over the 2 years, and the performance is super great. Like the accuracy is above 0.9%, is more almost close to 0.95%. That is very close to the radiologist using the X-ray as the fracture detection. However, that's just like in our experimental settings. And now we build the AI model into the application, and we are going to implement it in the clinic and see like how is performance in the clinics. I hope that results could go close to my experiments results. Well, thank you.
Thank you. Okay.
Yes,
Over there.
I'm ready. So it's a very general question. So first of all, I'm super impressed by the talent. It's a group of young people. So a very general question, how anyone can respond to that. How do you think the incentives are aligned in this province and Saskatchewan also regarding what motivates you to come to this province to do this research? If I can extend this a bit further, if you have a very superstar candidate just finished undergrad and want to do grad studies and the tendency is to go to Eastern Canada, what argument will you make to convince that student to come to Alberta?
Oh, I love this question so much.
Thank
Who
you.
wants to answer? It's basically a why did you come here question. Okay, we got some volunteers down here.
Well, like I can tell from my part, at least the first part is in Alberta, we are known for our energy industry, right? And we're generating a lot of waste, and it's need of the hour that we start tackling these issues head on. And so it's very important for us to repurpose this waste so that we're not creating the environmental burden in there. And the project that I'm showing today, it's actually part of Alberta government's initiative that they want to rethink bitumen beyond combustion. So it's part of that. Yeah.
Oh, for sure. Those were some very great points. The reason why I chose to follow my research here in Alberta is it's a little ironic. Alberta is known for its oil and gas industry. I'm here to help tear that down, but not in a negative way. They can both go hand in hand. Renewable crude and conventional crude, they can supplement each other as we phase out, as we find better alternatives. The reason why I think Alberta and the U of A specifically is very good to pursue grad studies is that a lot of the research that we do here is very impactful. At the U of A, we like to lead with impact. We like to make sure that the research that we do has applications outside the lab, outside the classroom, but in the real world. And yeah, thank you.
Anybody else want to go?
I just wanted to add about why Alberta. You were just asking about that. So, so when I was looking at what I could do as my project, I was looking at different things. So wastes are something that are all pervasive. It's not just province specific. So imagine the meat industry is growing. People are talking about changing to vegetarianism or reducing meat consumption, but that's not happening soon. And so if you look at the waste as such, so slaughterhouse waste, for example, they are actually becoming a problem now because with the quantity of meat that's being eaten, or I don't know if you've heard of spent hens. Do you know what spent hens are? Okay, so chickens are the most eaten meat, and spent hens are hens that have passed their egg laying cycle. So what do we do with them? People feel like in developed countries, it's against, like it's ugly to eat that meat. So it's like tough to eat. And what do they do with it? They just euthanize those hens and they're buried in landfills. So imagine amount of waste. So it could have gone to food. It could have fed millions of people. So it's not just Alberta specific, but like he said, things that make an impact. So waste makes an impact to everybody. Yeah, everybody is actually reeling under the problems of global warming or waste occupying your land, which you could have used for agriculture. So things like that so that was one of my reasons to come to Alberta. I was actually in the Eastern Province. I was in Toronto before coming here. And I chose to come here just because of the amount of good projects happening in this province.
I'm just going to put my 2 cents in here. I moved to Canada 6 years ago, straight to Calgary. So I'm not from Edmonton. This is my first time in Edmonton since 6 years ago. I moved to Calgary. I've never been here before. Thank you. I love it here, even though my visit is quite brief. I've never been to North America before I actually had to move to Calgary to do my PhD. And it was quite an adventure because I moved here by myself when I was 20. That was a lot of faith and good luck. And actually, I did not know if I would love it here or not. I just loved the project and I loved the person who was supposed to supervise me. We briefly met on Skype back in the day, not on Zoom. It was Skype times. And then throughout those 6 years, I started running into people that when you want to do something and your project seems crazy, you can meet people that are going to believe in you and are going to support your goals no matter how crazy they sound. There were so many community projects that we've started and pursued and completed successfully, and I've ran into incredible people and their support, not just as organizations, but as individuals. So when things need to get done and people are on board, they really do get done. So that's my 2 cents.
One more, and then we have to have snacks, I'm told.
Okay. So for my project, it was in Alberta, like among Canada, all the provinces, Alberta is one of the highest where you have opioid overdose deaths. And it just kind of leads like why it's happening, right? And so you want a solution for it. You see people on the streets all the time. And so that's kind of what led this project to happen here specifically. And that's nice.
Since everybody spoke about Alberta, I want to speak about Saskatchewan. Because I'm from University of Saskatchewan and they paid for my travel also. Sorry. So I'm very curious about agricultural research and biofuels. So for every research, we need resources. My research is based on canola, and I realized that Canada is the world's #1 producer of canola seeds. It produces 20 million tons of canola seed every year with only 5 months of agriculture. And Saskatchewan produces half of it. Yeah. And since like Saskatchewan is most agricultural province, it produces more canola, mustard, and even barley and other things. In Canada, we have 12 renewable ethanol plants where we produce renewable ethanol from corn and wheat. And out of them, 3 to 4 plants are located in the province of Saskatchewan. It shows how rich it is in agriculture and how rich it is in production of sustainable fuels. And yeah, it helped me a lot in collecting the data. And even we have a pilot scale facility in our lab through which in one day we can produce 1 liter of biofuel from the agricultural waste canola meal. Thank you so much.
Amazing. So I want to, yes. I don't want to stop this conversation because it's so good, but maybe you can take your questions out into the lobby where there's snacks and beverages, and we're going to have about a 20-minute break before we come back to announce the winners of the contest. So enjoy. Thank you so much. One more round of applause. Okay, everybody, it's the moment we've all been waiting for. The members of our jury have done the hard work, made those nearly impossible decisions. Again, bravo to all 5 of you, and thank you. We are glad it was you and not us. And congratulations to all 15 of our superb finalists. I know that everybody here was just wowed by all of your talks. You're all winners. I want to stress what an important accomplishment this is and how much we appreciate the work and time you've put into this project. And I just received a whole bunch of really positive comments in my conversations over snacks about all of your presentations and skills and abilities in presenting yourselves and your research. So something for you all to be really to take a lot of pride in. We trust that every minute you devoted to your Falling Walls entry will pay off for you. And we thank you for being a part of this Falling Walls family. What did we say? We were talking out there, your Falling Walls alumni now, Falling Walls class of 2024. That's you guys. But sadly, this is a competition and we do need to name the winners. So now is the moment. I'm going to call the jury members forward and you're each welcome to come up and say a few words to the entire group of finalists. And then once you've done that, we'll ask you to announce your winners. So could I ask Leslie Ann and Darren to step forward? Oh, wait, no, we're gonna have speaking first and then winners, or we're gonna do winners. Okay, never mind. Can I ask Leslie Ann and Darren to step forward to announce the 3rd place recipient? And when the individual hears their name, we'd ask that they come forward to receive their certificate. I shall turn it over to you now.
Wow. Thank you all so much. You wowed us. Like I said at the beginning, I was excited to be wowed, and I was wowed. When we think about the future, we think about hope, we think about big, complex problems that seem so out of reach. You guys are so there, you're reaching them. It's just so inspirational to see. Thank you so much for all the work that you're doing. Keep going, no matter what the findings of tonight, it doesn't reflect on every single one of you are doing such great work. Keep going. Don't lose your passion. I'm so proud of you. Good job. Darren, go ahead.
Yes, I will echo that. Thank you so much for your presentations and the passion that you put into this. You know, as I said earlier, it's really important that the world hears how our research is translated into impact. And I think each and every one of you did this tonight, and great job. So really exciting, and just keep telling people about what you're doing, because the world needs to hear what we're doing here at universities is important and relevant. So please continue. So let's announce the 3rd place winner. So the recipient of the 3rd place in Falling Walls Lab Edmonton 2024 is Pulkit Kumar.
We get a photograph right here.
One more. Thank you. Congratulations.
And I'll take your frame back. So we'll get your name on it.
Okay, congratulations, Pulkit. Amazing. And now, Paramita, if you would please announce the 2nd place winner for us and the first of our competitors who's headed to Berlin. We need a drum roll.
Thank you so much for this opportunity and to listen and to be inspired today. So this has been a wonderful, phenomenal day, and I cannot say how much it has been impactful to see the work that you're doing, not only in health, because there's a ton of impactful things happening in health, but also to see the social sciences, the prison project, the project for sustainable energy. It's all been very impactful. How can we forget our favorite Alberta beef? So thank you, all of you, for that. And it is my distinct honor and pleasure to announce the runner-up in the Falling Walls Lab Edmonton 2024 is Lily Chow.
Congratulations, Lily. And now, Sophia and Bhuvan, if you would please announce the first place winner who will also be traveling to Berlin with Lily.
Before he jumps in, I just wanted to take a moment, sorry, and thank you all for your presentations today. Inspiration and drive is really what came to mind, and it's amazing to see what each of you are working towards achieving. So continue to stick with that passion, and yes, over to you.
I'm gonna echo what everybody said. I think each of the ideas has a potential to break the walls. Each of the ideas were phenomenally presented. You guys talked about problem statement solutions, great presentations. I'm gonna second what Darren said. Find voices, talk about your ideas. You do need people supporting your ideas. So you're all winners. And anybody who's not going to Berlin, keep finding those voices, keep finding those mentors in the society. Thank you.
So the winner of the Falling Walls Lab Edmonton 2024 is Sarah Hassanpour Tamrin for breaking the wall of early cancer detection. Thank you. Thank you. Congratulations.
So we also got some feedback for you, Sarah, because you're the winner today. So we just wanted to say, great opening, phenomenal, getting everybody's attention to your idea. You had great explanation of what the problem is, how you're planning to solve it, how you're planning to implement the solution. It's got global impact, so best of luck at Berlin. Some of the development areas that you can implement in your presentation. I think if you were to talk about some lab results or some sort of results that's defending your study, it would be helpful. And just talk about why it hasn't implemented and what are the steps that you need to do to scale the solution at a global level. So, but best of luck.
Wow. Congratulations and some advice for Berlin, an extra added bonus. What a wonderful accomplishment. But truly, this has been just really a stellar day for all of our great presenters. In a moment, I'm going to call you all forward to receive the finalist certificates and take photos. But before I do, we can't conclude today's celebration without putting our hands together a few more times. The first is for our wonderful judges. Thank you so much for your time, for your wisdom and your insights. And one last time, let's give it all up for our 15 presenters. So inspiring. Thank you, all of you. I understand Rob has a few notes of thanks that he'd like to share on behalf of the organizers. And before I hand it over to Rob, I just also want to thank Rob and Renee and the PD team and everybody that's engaged with communications training at GPS. These are really important professional development skills that are available to our graduate students that result in, together with their inspiration and hard work, the presentations that we all enjoyed tonight. So let's thank that Rob and Renee for all of their hard work. Jay and Aaron, who are here as well. They've been working really hard on all of this. And I want to thank the folks from GPS that put on all of the great food. They're not in the room. I'm not seeing them, probably because they knew I would do this. But let's give them a hand as well.
Thank you so much, Tracy. It's definitely the best part of our jobs, as you can imagine, working with such wonderful, thoughtful people. We actually, just on behalf of the organizers, we want to begin by thanking you, Tracy, and for all of your support and advocacy through the year. It's tremendous working with you. Speaking of tremendous, a quick note of thanks from the organizers to our donors and the Kwekwe Honor Society members who are joining us tonight. Thank you for your support and your investment in learning and discovery at the U of A. It's because of folks like you that things like this can happen. We're also grateful to our friends at the U of A Development and Alumni Relations Unit, Michelle Murray, Kathy Fitzgerald, Colleen Elliott, Lisa Haruther and their colleagues for helping us to spread the word. Mr. Jablonski in the Chancellor's Office has offered kind help. So you see, this is a real community effort across the U of A. We're so pleased to have some of our leadership here as well. Elizabeth Adolph in the Office of the Vice President, Research and Innovation. And speaking of partners, University of Saskatchewan, in addition to Leslie Ann, our partner at the University of Saskatchewan College of Graduate and Postdoctoral Studies, Kanisha Blair Walcott is probably watching right now over live stream. So we want to say it's been a joy to work with both of you. Thank you very, very much. And a tip of our hat to Tara Christie at the University of Calgary. There were 3 U of C presenters today. That's thanks to the efforts of Tara and the team at the U of C, who did a great job promoting the event there. A couple other quick notes, and we'll turn it right back to Tracy. Whether you're here in person tonight or you're watching via live stream, you're benefiting from the great work of Claire Peters and Chris Wang and the team at the ARC, the Arts Resource Center, AV experts on campus. So thanks very much to them for the great work. Yeah, in the past, you saw how well they did, right? They had some coaching. And in the past few weeks, our finalists, I think, just like us, we've all learned a lot. And they've especially benefited from the expert coaching of Peter Keith of the U of A's eHub Ideas Lab. So we really want to put out a thank you to Pete as well. He did a brilliant job. Finally, as Tracy said, our colleagues in the Faculty of Graduate and Postdoctoral Studies, Andrea and Bobby, Ashley, other members of the PD team. Tracy, thank you very, very much. Thank you all. And back to you, Tracy.
Lots of clapping, lots to celebrate. And a final note, if you're an early career researcher with a story to tell, consider taking part in Falling Walls Lab Edmonton next year. We plan to do it all over again. And as you can see, the results are remarkable for all of us. We would love to have you join us. So thank you so much, everybody, for coming out and have a really good night. I hope that we see you next year and maybe at our 3MT and our Images of Research competition as well. Have a good night.